Hello friends, welcome to my channel Study Maths. Today we'll be looking into basics of vector space. But before I move ahead, I have a request for all of you regarding COVID-19 pandemic. I request you all to practice social distancing and strictly follow all the guidelines issued by your respective governments. By doing this, I and you can help break the chain and buy some time for our governments to effectively fight the pandemic. So let us delve into the basics of vector space. So vector space is nothing but a tool which helps in categorization, and this categorization helps in simplifying computations. Vector space have a wide range of application starting from mathematics to science and engineering. You might have heard of artificial intelligence, machine learning, robotics, remote sensing, weather forecast. All these areas use vector space to simplify computations and better understand the physics or science behind different processes. Vector space can be defined as a set or collection of objects which can be added together or multiplied by scalar numbers. Technically, a non-empty set V of vector elements A, B and so on is called vector space if and only if two operations, that is vector addition and scalar multiplication, can be defined on it. Let us understand the concept of vector space using 2D coordinate system. Here we have two vectors, that is I and j vector. I vector is along x-axis and j vector is along y-axis. Using these two vectors I and j, we can define any point in the entire 2D coordinate system. For example, a point P has been defined over here in this graph. The point P can be defined as 4i plus 2j, meaning that we have to use 4 units of I and 2 units of j in order to define the point P. Similarly, we can define any point in the 2D coordinate system. So the vector space over here is the entire 2D coordinate system. Now let us consider one of the operations which vector space must satisfy, that is vector addition. Let us consider one vector space having vector elements A, B and C. Then this vector space satisfies these two properties, commutativity and associativity. In commutativity, the vector A when added to B will be equal to vector B when added to A. In associativity, the result of vector A plus B when added to C will be equal to the result of vector B plus C when added to A. Coming to the next operation which vector space must satisfy, that is scalar multiplication. Let us consider the same vector space having vector elements A, B and C. Then this vector space satisfies these two properties, that is distributivity and associativity. In distributivity, when the sum of vectors A plus B is multiplied with a scalar m, that is same as when m is alone multiplied to vector A plus when m is alone multiplied to vector B, or when the sum of scalars m plus k is multiplied to a vector A is same as the sum of m when multiplied alone to A and k multiplied to A. In associativity, when a scalar k is multiplied to a vector A and again a scalar is multiplied to the result is same as a scalar multiplied together and then finally it is multiplied to vector A. Since we are multiplying scalars to vectors over here, the scalars can be either real or complex. Based on whether the scalar is real or complex, the vector space can be defined as either real vector space or complex vector space. Now, let us see some of the properties of vector space. That is, what is the dimension of vector space and what is the basis of vector space. The basis of vector space is nothing but it is a set of linearly independent vectors that can define the entire vector space, and the dimension is the number of linearly independent vectors present in the basis. Let us consider one vector space having vector elements A, B and C. Let us assume that A, B and C are linearly independent vectors. Then the basis of the vector space will be A, B and C, and the dimension of the vector space will be 3. Let us consider another example wherein we try to define the vector space of cubic polynomial. In general, the cubic polynomial can be defined as ax cubed plus bx square plus cx plus d. Here we use x cubed, x square, x and one scalar to define the cubic polynomial. So our basis will be 1, x square, x cube. 1 over here is used to define any scalar. So if we multiply a scalar with 1, we can have whatever the scalar which is required for the cubic polynomial. So since it has 4 elements or 4 vectors in the basis, so the dimension of the vector space of cubic polynomial is 4. So if you like the video, give thumbs up to the video and please comment about the video or any specific topic you wish to learn. Also, if you have not subscribed to my channel, please subscribe to get notified about any video I upload. Thank you friends. See you guys in the next video.